Hello, everyone. This is Huang from Sonoma Tech. Today, I'm going to talk about the benefit from low-NOx regulation and advanced clean truck loads California regulation, how it will impact 13 different states plus this area. We are focused on medium and heavy-duty vehicle from 2020 to 2050. So this project was founded by ICCT. And I would like to thank Jeff, John C., and Ray. Without their help, I cannot finish this project by myself. The outline would include the introduction of California regulations. And the second part, we are going to talk about the multi-state, how are they looking forward to their EV penetration in the future year, especially the medium and heavy-duty vehicle. And then we are going to talk about the motivation of this project. So after that would be the detailed method that includes the tool we use, the model we use, and how we adjust the EV penetration after the move output or the criteria air pollutant adjustment. The last part, I'm going to show you the result and talk about what we think we should look forward in the future. California are trying to regulate the sales of ZEV for medium and heavy-duty vehicle, but not include the bus. And so they set up different goals for different vehicles. For example, 50% of 2B to 3 truck sales by 2035, and they try to look into the benefit for energy usage, the criteria air pollutant emission reduction, and also the GHG emission reduction for on-road sector. They also set up the standard for NOx emission, trying to lower the NOx emission for heavy and medium duty vehicles. So that would be 75% below current standard in 2024 and 90% below current standard in 2027. So if you consider all this standard together, that will it will equal to 16 million vehicle cut. So it's really huge for only California part. I would like to also talk about the greenhouse gases phase 2 policy, but today we are going to focus on the fuel consumption and CO2 emission because we only use these for mostly the GHG reduction in this study, but also the EV penetration. So by 2027, the fuel consumption and CO2 emission will be reduced up to 16 to 25% for various vehicles. And there are 2 different components in the phase 2. One will be engine component, and one will be trailer component. We're only going to focus on the engine component in this study. There are currently 15 states signed MOU looking forward or set up the goal for medium heavy-duty ZEV sales by 2030, so that would be 30%, and by 2050, that would be 100%. 13 of these 15 states plus DC area trying to work with us, provide data to us. So we are going to do the data analysis and to consider if those states implement the California regulation, how the EV penetration, the criteria air pollutant plus the GHG emission will impact by the regulation for on-road sector. So it should help the policymaker understand the potential emission benefit of zero emission vehicle and low-NOx regulations. Focus on medium and heavy-duty vehicle. We look into the 2020 to 2050. So that will be the general idea for this study or the project. Before we jump into the method, I would like to talk about we use 2 different EV situation or conditions. One would be the ACT EV, one would be the old EV. The ACT EV will only consider the EV penetration contributed by the ACT, and the second one, OEV, that's contributed by ACT plus GHG phase 2. But in both conditions, we do not consider the out-of-state migration over time. So it will be only the ACT, in the state impact. Besides the 2 different EV situation, we run 5 different scenarios. And in this study, we are going to focus on the scenario 2 to 4. So the scenario 1 would be the business as usual. The scenario 2 would be ACT plus low NOx regulation. But 2 itself would be only use ACT EV, and 2A we are going to use OEV. And 3, 4, 5 represent the impact for EV penetration criteria, pollutant and greenhouse gases emission impact from individual regulations. We will talk about this later for how different vehicle type will impact or different air pollutant species will be impacted. The configuration of these data analysis, there are 3 different steps. The first step will be collecting the data for move input, and we run the move. At this point, the move output data will only consider the GHG2 phase 2, but did not consider the ACT and the low NOx reduction regulation. So in the second step, we need to take those into consideration. We'll cooperate with ARB to create some lookup table to adjust the EV penetration and also air pollutant reduction. For GHG phase 2, although the move already take the GHG phase 2 into consideration, but we only look into the engine component in this study, so we need to take out the trailer component. The third part will be the upstream EV emission. So we use a great lookup table to calculate EV emission for upstream from the on-road emission. And we look into the data by different region. So this slide is showing you the input data we use. We run move into county level, and we use Equitas 2017 EPA data, especially the representative counties to run for each move run for each state, and just grew up for each state total emission. So in the second stage for the method, we did the post-analysis or post-process to adjust the EV penetration. This table just gives you the idea for various or different regulation, how they impact different EV, the EPA regulatory class vehicle and how they input the different pollutant. The last part for the method I would like to talk about would be the graded emission factor for vehicle using electricity. We use those data from the graded lookup table by different regions. However, some states they do provide the detailed graded renewable energy projection for future years. So for those states, we will use those information instead of regional data. And we need to pay attention for the Pennsylvania and North Carolina. Their greenhouse gases emission for the upstream emission is high compared with other 2 regions, and it's also high compared with downstream GHG emissions. So it will impact the overall GHG reduction. So for low state, the GHG reduction could be low. Now, we already talked about the background and talk about the motivation, also the different methods. We are going to jump into the result for the project. The first slide, we are talking about the NOx emission reduction for on-road sector. And we try to compare a different scenario to the BAU, that would be scenario 1. And we use 2050 as example. This one will be the NOx, and next one will be the PM2.5. So we will look into the data later. As expect, the scenario 2A, that includes the ACT low NOx regulation, GHG phase 2 OEVs, showing 50% reduction compared to BAU. And scenario 3 and 4 just showing you ACT and low NOx regulation individual impact for NOx reduction for the on-road sector. So this slide showing you exactly the same thing, but just different pollutant, that would be PM2.5. For scenario 2A, huge number, like 20% reduction compared with BAU. So this one will be the greenhouse gases reduction. We are looking for the scenario 2A again, but not like previous one. Previous 2 criteria air pollutant emission reduction, they are very consistent. in these 14 different areas, but the greenhouse gases reduction showing really high variation from 6 to 55%. That's because I just talked about the NC and the North Carolina and Pennsylvania, their upstream greenhouse gases emission controlled by the graded lookup table is really high. So even we are seeing that huge amount of GHG reduction from the exhaust pipe, upstream still control the main GHG emission. So it can only go up to 6 to 10%. But for other states, we are seeing up to 55%. So it's still very important. So we talk about the EV, how the EV change or the policy change would impact the criteria and the GHG emission. And they'll kind of showing the reduction. By looking to the EV penetration for medium and heavy duty vehicle, by 2030 and by 2050, we look into two different regulations, the ACT and the GHG phase 2. So initially, the ACT are showing very low EV penetration by 2030s. After 2040s, it starts to catch up the GHG phase 2 EV penetration. So by 2050, it can go up to 48%. The conclusion for this study, for scenario 2A, we consider all the regulation plus the GHG EV condition and the ACT condition. We are seeing 50% of NOx reduction compared with BAU scenario for NOx, and the PM2.5 emission for on-road sector is only about 20%. But for GHG emission, it's showing really high variation along this state. It's because the upstream emission from the grid lookup table are showing very different data, and in North Carolina, Pennsylvania, those states, it's still a major control for the GHG emission in the upstate, in the upstream part. So we don't really see those high GHG reduction in these two states. Second will be the EV penetration. So initially, the ACT rule did not go very fast for the EV penetration. It's only 1% by 2030s, but by 2050, it can go up to 25%, and plus another 23% for GHG phase 2 regulation. So total can be up to 48%. So the take-home message from this project would be current on-road emission projection for the future year. We do not really take the EV penetration, or we did not really consider the EV penetration can go 48% for medium and heavy duty vehicle. And if those states implement the regulation in the future, we need to rethink about how are we going to project the future emission for on-road, especially for these 14 areas or plus the other states. So it's very important to think about how we're going to do the future year projection for the on-road emission. And Sonoma Tech would like to thank SPAN at ICCT and all the organization, the state agency to provide data and help us to create a lookup table for EV penetration table and the criteria emission reduction table. So ICCT published a white paper based on the data we talked about today on their website. They also published the tools and the spreadsheet we use. So if you are interested in how we did these projections, please make sure you take a look and send us some comment or feedback. So this will be the Sonoma Tech contact information. Thank you.